Hey there, and welcome to This Explainer. Look, if you've ever opened a math textbook, seen a page entirely covered in curly brackets, weird Greek letters, and endless equations, and just felt an immediate wave of panic, take a deep breath. You are in exactly the right place. Today, we are completely demystifying the mathematical concept of sets. I promise you, by the end of our time together, this topic is going to feel totally intuitive, deeply logical, and completely stress-free. We're going to break the whole shebang down step by step, kind of like a private tutoring session, so you can walk into your next exam with absolute confidence. To kick things off and ease any of that math anxiety, I want you to realize something absolutely crucial. You already use the logic of sets in real life, literally every single day, without even realizing it. Think about it for a second. How does your smartphone automatically group your favorite contacts? Or, when you're on a shopping app and it instantly filters 1,000 shirts to show you only the ones with a 20% discount in your exact size. Or consider how a city planner measures land zones, or an architect groups materials for a building design. They are all using the concept of grouping specific things together based on a strict set of rules. And that real-world grouping, that is exactly what mathematical sets are all about.
All right, let's introduce the core concept visually first, before we look at any intimidating formulas. I want you to imagine a bright, golden yellow circle sitting on a deep purple background. Inside that yellow circle, we're going to place specific items, maybe the vowels of the alphabet, or all the even numbers less than 10. This gives us our core definition. A set is simply a well-defined collection of distinct objects or elements. The logic here is just deciding what belongs inside our golden club and what gets left out in the purple background. That is literally the entire foundation of set theory.
Now, what's really interesting about this slide is how mathematicians use symbols to save time. Instead of writing out long, tedious sentences over and over, they created a shorthand language. If something is inside our set, we use this little curved symbol that kind of looks like a rounded E. It's the Greek letter epsilon, and it simply means belongs to. So if capital M is our set of molars, we write second molar, then the epsilon symbol, then M. If something does not belong in the set, we just draw a quick strike-through line right across that epsilon symbol, which translates to does not belong to. Pretty simple, right?
As we dive just a little deeper, we need to know that mathematicians generally have two specific ways, or languages, to describe what is inside a set. The first one is called roster form. This is the most straightforward method. You just open a pair of curly brackets and physically list every single element, separated by commas. For example, A, E, I, O, U. But sometimes listing everything takes way too long, and that's exactly where set builder form comes in. Instead of listing out all the elements, you just write the mathematical rule that defines them. So instead of writing out the letters, you write the rule X is a vowel.
Now you might be wondering, okay, why do we even need set builder form if roster form is so easy? Well, take a look at this textbook question. Can you write the set of rational numbers in roster form? The answer is a hard no. There are literally an infinite number of rational numbers. We cannot possibly list them all out one by one. This is exactly why set builder form is absolutely necessary. It allows us to capture an infinite amount of elements by simply defining the common property or rule they all share.
Okay, let's look at how to actually read this set builder syntax out loud. Because honestly, once you can speak it, it completely stops looking so scary. Let's look at the syntax box. You see an A equals, then a curly bracket, an X, a colon, and then a rule. Here's exactly how you translate that into English. The opening curly bracket is read as the set of all X. The colon is incredibly important. It translates to the phrase such that. And then you just read the rule. So altogether, you'd read it out loud as A is the set of all X such that X is a multiple of 3 and X is less than 20. See? It's just a regular sentence written in math code.
Section Guided Practice. Solving 3 board exam problems together.
All right, let's do this together, starting with a nice, easy warm-up. This is exercise 2.1, question 2 from the textbook material. First off, what is given to us? We are given 3 defined sets. Set A is 0, 2, 4, 6. Set B is 3, 5, 7. And set C is P, Q, R. Now, what is the question asking us to do? It wants us to fill in the blanks with either the belongs to epsilon symbol or the does not belong to symbol.
Okay, let's dive into this step by step. Step 1. We look at the number 0 in set A. Does 0 live inside set A? Yes. Looking at our list for A, 0 is right there. So we draw our epsilon belongs to symbol. Step 2. Look at the number 3 and set C. Well, set C only contains the letters P, Q, and R. The number 3 is definitely not in there. So we draw our epsilon with a line through it, does not belong. Step 3, the number 4 and set B. Set B is 3, 5, 7. No 4 in sight. Again, we use the does not belong symbol. Excellent work!
Feeling good? Let's bump up the difficulty to medium. This is question 6. We are given a set in roster form, 3, 6, 9, 12. What we are asked to do is convert this into set builder form. To do this, we have to act like detectives. We need to find the hidden mathematical pattern or rule that governs these specific numbers, and then we have to define exactly where the pattern stops. First things first, identify the pattern. 3, 6, 9, 12, these are clearly multiples of 3, right? So for step 2, we write the mathematical rule. X equals 3 times n, or simply 3n. But step 3 is where students often lose marks. We absolutely must define the limits. N has to be a natural number, like 1, 2, 3, 4. And because our set stops at 12, n cannot be larger than 4. So we write n belongs to natural numbers, and n is less than or equal to 4. Put it all together in brackets for step 4, and we have our perfect set builder form.
Okay, deep breath, because now it's time for the hard board exam level challenge. Question 7, part 4. We need to convert this heavily algebraic set builder form into a simple roster form list. The set E is defined by the rule x equals 2 times n squared plus 1, and it comes with the constraints n is between -3 and +3, and n belongs to z, which means integers. Now, I know this looks intimidating, it looks like a crazy soup of numbers and letters, but I promise you, if we unpack the constraints carefully, it's actually incredibly straightforward.
So the crucial point is to completely ignore the complex formula for a moment. Seriously, pretend it's not there. Focus entirely on extracting your integer constraints for n first. The problem tells us n must be an integer between -3 and +3 inclusive. So step 3 is simply listing those allowed values out. N can only be -3, -2, -1, 0, 1, 2, or 3. That's it. Those are our keys. Now all we have to do is plug those keys into the rule one by one.
Let's start plugging them in. If we plug in n equals 0 to our formula, x equals 1. Because squaring a negative gives a positive, plugging in either +1 or -1 gives the exact same result, x equals 3. Plugging in positive or -2 gives us x equals 9, and plugging in positive or -3 gives us x equals 19. Look at that. We've generated our list. Our final roster form is simply the set 1, 3, 9, 19. You literally just conquered a hard board exam question by taking it one logical step at a time. Okay, now that you've totally got the mechanics down, I want to transition over to error correction. Because it's not enough just to know how to solve the problem, you need to know how to avoid the traps that examiners set for you. The textbook highlights a very specific notes section regarding the rules for writing out roster sets, and memorizing these will absolutely save your grade. Rule number 1. Order is completely immaterial. Writing a set as 7, 2, 1, 9 is mathematically identical to writing 1, 2, 7, 9, so don't stress about numerical order. But here's rule number 2, and please listen carefully, because this is the absolute most common mistake students make in exams. Elements are never repeated in a set. If an exam asks you to write the set of letters in the word school, the answer is S-C-H-O-L. Notice there is only one O. Writing the O twice means you don't understand that a set is a collection of distinct objects, and the examiner will mark it wrong immediately. Never repeat an element. You've got this, your 5-point cheat sheet and exam trick.
And this brilliantly illustrates our final takeaway. To make absolutely sure you are fully armed for your exams, here is your quick 5-point cheat sheet. 1. A set is a distinct collection. 2. The epsilon symbol means belongs to. 3. Roster form means listing elements. 4. Set builder form means writing the rule. And 5. Here is your secret exam trick. When asked to turn a word into a set, physically cross out duplicate letters on the paper before writing your brackets. Cross out that second O in school so your brain doesn't accidentally write it down.
See? Math really doesn't have to be intimidating when you break it down, look at the visuals first, and actually understand the logic behind the formulas. You have the tools, you have the syntax, and you know exactly how to avoid the traps. So I'll leave you with this provocative thought as you go about your day. Look around you. From the customized playlist on your phone to the layout of your local grocery store, what hidden rules are governing the sets in your daily life? Keep practicing, stay confident, and I'll catch you in the next explainer.